Good morning, students. Let us continue from where we have stopped the previous video. We have been discussing the reduction formulae. So, last exercise, second Roman, show that integral x power n into e power minus x dx. So, this is what we need to prove. So, let us take the LHS. Integral x power n into e power x dx. This is clearly the product of two functions with x power n algebraic function and e power minus x exponential function. So, according to the phrase of I let, a comes first and e comes next. So, this is f of x, first function, and this is g of x. So, we have f of x into g of x dx is equals to f of x, first function, into integral of second function dx minus integral of d by dx of first function into integral of second function dx whole dx. So this is integral of x power n into e power minus x dx is equals to x power n into e power minus x dx minus of integral d by dx of x power n into e power minus x dx whole dx. So this is x power n. E power minus x is e power minus x by minus 1. So this is minus d by dx of x power n is n into x power n minus 1 into e power minus x is minus e power minus x. Integral e power minus x dx is minus e power minus x dx. So this is equals to minus x power n into e power minus x. So minus of minus plus. N is the constant. Let us separate it from the process of integration. N into integral x power n minus 1 into e power minus x dx. So if you see this, which is to be proved, this is equals to this. So therefore, this is the RHS. If In is equals to integral cos power nx dx, then show that In is equals to 1 by n cos power n minus 1x into sin x plus n minus 1 by n In minus 2. So similar kind of problem we have solved it before in examples, that was integral sin power nx dx. So this is cos power nx dx. So given that In is equals to cos power nx dx. So this cos power nx dx can also be written as cos power n minus 1x into cos x dx. So since bases are equal, exponents are to be added. So this has a power 1, n minus 1 plus 1, 1 gets cancelled. We are left with cos power nx. So let us take this to be f of x and this is g of x. So first function, let us take this to be the first function. First function into integral of second function dx minus integral of d by dx of first function into integral of second function dx whole dx. So this is equals to cos power n minus 1x. Integral cos x dx is sin x minus d by dx of cos power n minus 1x. So this is cos power n minus 1x can be assumed as cos x whole power n minus 1. So d by dx of. So this, let us suppose this to be x. Then it is d by dx of x power n minus 1. We have a formula for d by dx of x power n. N into x power n minus 1. So d by dx of x power n minus 1, n minus 1 will come forward, n minus 1 into cos x whole power n minus 1 minus 1, so n minus 2. So n minus 1 into cos n minus 2x into, since cos x is treated to be x, so we need to differentiate it later. into d by dx of cos x is minus sin x into integral cos x dx is sin x dx. Since cos x is treated to be x, so into d by dx of cos x is minus sin x. Integral cos x dx is sin x bracket closed dx. This is equals to cos power n minus 1x into sin x. So minus into minus plus. N minus 1 is the constant. Let us write it outside. Integral. This is cos power n minus 2x sin x into sin x sin square x. So sin square x plus cos square x is 1. So sin square x is equals to 1 minus cos square x dx. This is equals to cos power n minus 1x into sin x plus n minus 1 integral cos power n minus 2x into 1 minus cos square x. A into b minus c. ab minus ac. Cos power n minus 2x into 1 is cos power n minus 2x minus cos power n minus 2x into cos square x. Bases are equal. Exponents are to be added. N minus 2 plus 2. 2 gets cancelled. Cos power nx dx. So this is equals to cos power n minus 1x into sin x plus this n minus 1 will be multiplying with both of them and integral dx is to be distributed for both of them. So this is n minus 1 integral cos power n minus 2x dx plus into minus minus n minus 1 integral cos power nx dx. So this is equals to cos power n minus 1x into sin x plus n minus 1. Since integral cos power nx dx is in, integral cos power n minus 2x dx can be written as in minus 2 minus of n minus 1 integral cos power nx dx is in. This is all in only. So in, this minus of n minus 1 if you transpose onto another side, this is plus n minus 1 in is equals to cos power n minus 1x into sin x plus n minus 1 in minus 2. So in if you take common, its coefficient is 1 plus n minus 1. So minus 1 plus 1 gets cancelled. Cos power n minus 1x into sin x plus n minus 1 in minus 2. So here with n is multiplying. So if you transpose to that side, this n is dividing with this. So therefore in is equals to cos power n minus 1x into sin x plus n minus 1 into in minus 2. Since n is multiplying here, it would be dividing with both of them. This is by n, this is by n. So which we need to prove. So cos power n minus 1x into sin x by n plus n minus 1 by n into in minus 2, where n is greater than or equals to 2. n is an integer which is greater than or equals to 2, positive integer. Obtain the reduction formula for in is equals to cot power nx dx, n being a positive integer and greater or equals to 2, and hence the reduce the value of cot power 4x dx. So given that integral In is equals to integral cot power nx dx. Integral cot power nx dx can be splitted as cot power n minus 2x into cot square x dx. Bases are equal, exponents are to be added. N minus 2 plus 2 is n. So let us take this to be the first function and this to be the second function. Otherwise, cot power n minus 2x, this cot square x is cosecant square x minus cot square x is 1. From this, cosecant square x minus 1 is equals to cot square x. So therefore, this cot square x can be written as cosecant square x minus 1 dx. Now, a into b minus c, ab minus ac. Integral dx is to be distributed for both of them. So cot power n minus 2x into cosecant square x is this integral dx minus cot power n minus 2x into 1 is integral cot power n minus 2x dx. Now, if I have taken cot x is equals to t, then if cot x is equals to t, minus cosecant square x dx is equals to dt. So this is cot x whole power n minus 2. So cot x is t. So t power n minus 2 cosecant square x dx minus cosecant square x dx is dt. So if you multiply with minus on both the sides, minus of minus is cosecant square x. This is minus dt. So cosecant square x dx is minus dt. So cosecant square x dx is minus dt. Minus we have written outside. Minus, if integral cot power nx dx is in, integral cot power n minus 2x dx is in minus 2. So this is of the form integral x power n dx, x power n plus 1 by n plus 1. So this is t power n minus 2 plus 1 by n minus 2 plus 1. So n minus 1 by n minus 1, minus is already there, minus in minus 2. So this is minus 1 by n minus 1. So t is replaced back as cot x. So cot x whole power n minus 1 in minus 2. Therefore, this is the reduction formula for integral cot power nx dx. Now, he further asks us to evaluate integral cot power 4x dx. So simply n is equals to 4. If you substitute here, we will obtain that integral cot power 4x dx. So n is equals to 4. So cot power 4x dx is equals to, this is minus 1 by n value is 4. 4 minus 1 is 3. So minus 1 by 3 cot power 4 minus 1 is cot cube x minus 4 minus 2 is 2, I2. So this reduction formula is applicable as long as n is greater or equals to 2. So since I2 is equals to 2, so let us use this reduction formula which we have deduced so far to obtain I2. So minus 1 by 3 cot cube x minus now I2. So substitute n equals to 2 in this. So minus 1 by 2 minus 1. 1 by 2 minus 1 is 1. So minus 1 by 1 is minus cot power 2 minus 1. So cot x minus 2 minus 2, 0. So here n equals to 0, which is not greater or equals to 2. 0 is not greater than 2. So let us substitute this 0 directly in this given integral. So I0 is equals to cot power 0 x dx. I0 is equals to cot power 0 x dx. Anything to the power of 0 is 1. So integral 1 dx is x. So therefore, minus 1 by 3 cot cube x minus of minus plus cot x. So minus into minus plus I naught value is x. So x plus constant of integration c. Second question, obtain the reduction formula for in is equals to cosecant power nx dx, n being a positive integer and greater or equals to 2, and hence deduce the value of integral cosecant power 5x dx. We have already done integral secant power nx dx before we start this exercise. So this is also the same process. Solution: given that in is equals to integral cosecant power nx dx. So we can split cosecant power nx with the cosecant power n minus 2x into cosecant square x dx. So this is the first function and this is the second function. So first function into integral of second function dx minus integral of d by dx of first function into integral of second function dx whole dx. So this is equals to cosecant power n minus 2x integral cosecant square x is minus cot x minus d by dx of cosecant power n minus 2x is, we can write it as d by dx of cosecant x whole power n minus 2. So let us suppose this cosecant to be x. So d by dx of x power n minus 2 is n minus 2 into x power n minus 2 minus 1 n minus 3. Since cosecant x is to be treated to be x, later on we need to differentiate into d by dx of cosecant x. So this is what we will do now. So n minus 2 into cosecant power n minus 2 minus 1 is n minus 3 x into d by dx of cosecant x is minus cosecant x cot x minus cosecant x into cot x integral cosecant square x is minus cot x integral cosecant square x dx is minus cot x. So bracket closed dx. This is equals to minus cosecant power n minus 2x into cot x minus into minus plus into minus. Since n minus 2 is constant, let us write it outside the integration. Integral cosecant power n minus 3x into cosecant x. So n minus 2x into cot x into cot x cot square x. Cot square x can be written as cosecant square x minus 1. N minus 2 we have written outside this integration. Cosecant power n minus 3x into cosecant power 1x. Base is equal n minus 3 plus 1 n minus 2x. Cot x into cot x is cot square x. Cosecant square x minus cot square x equals to 1. Cosecant square x minus 1 is cot square x. So this is equals to minus cosecant power n minus 2x into cot x minus n minus 2. So cosecant power n minus 2x into cosecant square x integral dx n minus 2 is multiplying and cosecant power n minus 2x into 1 cosecant power n minus 2x n minus 2 integral dx. So n minus 2 is multiplied with both of them. So n minus 2 integral cosecant power n minus 2x into this. So this is cosecant power nx dx minus into minus plus n minus 2 integral cosecant power n minus 2x into 1 is cosecant power n minus 2x dx. So this is equals to minus cosecant power n minus 2x into cot x minus n minus 2 integral cosecant power nx dx is in. So let us replace this with in plus n minus 2. Since it integral cosecant power nx dx is in, integral cosecant power n minus 2x dx is also, we can treat it as in minus 2. So this is all in LHS. So this minus of n minus 2 let us transpose this into another side, plus n minus 2 this is equals to minus cosecant power n minus 2x into cot x plus n minus 2 in minus 2. So take in common. So this is 1 plus n minus 2. This is equals to minus cosecant power n minus 2x into cot x plus n minus 2 in minus 2. So this is 1 plus n minus 2 is n minus 1. So n minus 1 into in. So this n minus 1, it is multiplying, it would be dividing with both of them. Therefore, in, what is this in? Integral cosecant power nx dx. This is the reduction formula for integral cosecant power nx dx. This is equals to minus cosecant power n minus 2x into cot x by, so 1 plus n minus 2 is n minus 1. So this is multiplying, it would be dividing with both of them. So by n minus 1 plus n minus 2 by n minus 1 n minus 2, where n is greater than or equals to 2. So this is the reduction formula for integral cosecant power nx dx. And now we need to obtain integral cosecant power 5x dx. Simply substituting n equals to 5 in this reduction formula, then we will obtain integral cosecant power 5x dx. So this is the reduction formula for integral cosecant power nx dx. Now integral cosecant power 5x dx is being asked. So this is, in the place of n, substitute n equals to 5. This implies cosecant power 5x dx is equals to minus cosecant power 5 minus 2, 3x into cot x by 5 minus 1 is 4, my plus 5 minus 2 is 3, 5 minus 1 is 4, 5 minus 2 is 3. So this 3 is still greater than 2. This is valid as long as n is greater than or equals to 2. So 3 is clearly greater than 2. So now I3 is equals to, so n equals to 3, you substitute here. So minus cosecant power 3 minus 2, so 1x into cot x by 3 minus 1 is 2 plus 3 minus 2 is 1, 3 minus 1 is 2, 3 minus 2 is 1. See, 1 is not greater than 2. Therefore, we shall not use the reduction formula to evaluate I1. So, what should we do? So, we have In is equals to integral cosecant power nx dx we have taken earlier to deduce this reduction formula. So in that substitute n equals to 1 here. So here I1 is equals to cosecant power 1x dx. So cosecant power 1x dx is 1. Integral cosecant x dx is log modulus of cosecant x minus cot x plus constant of integration c. Therefore, integral cosecant power 5x dx is equals to minus cosecant cube x into cot x by 4 plus 3 by 4 into I3 value is this. So, this is minus cosecant cosecant x into cot x by 2 plus 1 by 2. Again, I1 value is log modulus of cosecant x minus cot x. So log modulus of cosecant x minus cot x. So bracket closed plus constant of integration c. Therefore, this is equals to minus cosecant cube x into cot x by 4 plus into minus minus 3 by 4 2s are 8 cosecant x into cot x. So this is plus into plus plus 3 by 4 into 1 by 2. So 3 by 8 log modulus of cosecant x minus cot x plus constant of integration c. Or we may also write log mod tan x by 2. Integral cosecant x dx is having another formula, or log modulus of tan x by 2 plus c. Therefore, this or minus cosecant cube x into cot x by 4 minus 3 by 8 cosecant x into cot x plus 3 by 8 log modulus of tan x by 2 plus constant of integration c.